Yes, good morning all of you. Am I audible? Yes, good morning all of you. Yes, okay. So Namrata, Mansi, Shirin, Farin, Neha, Pradnya, Atharva, Pooja, Prajoti, Utkarsha, Meera, Anna, Ritik, Akash, Nisha, Pooja, Sandhya, Akshaya, लीना, विशाखा, प्रणीता, रोशन, प्राजक्ता, प्रक्षेप, आदर्श, किरण, पूजा, सकपाल, वैशाली, श्वेतांजलि, दिनेश, स्नेहल, हर्षल, प्रवीण, श्वेता पाटिल, आकाश गुप्ता, राधिका गुप्ता. I welcome you all once again. Okay, am I audible? Let me know. Nitish, Jagruti. Hello, yes, I'm audible, I think. So let's get started. So in this session, we are going to cover one of the most widely and the simplest technique of chromatography, that is paper chromatography. The main function or main attraction with respect to the paper chromatography, it is very simple, very widely used, most widely used technique. And why it is so widely used, what are the distinctive factors or the parameters which makes it widely acceptable throughout the analytical chemistry or analysis. Yes, Samiksha, Nuja, Priyanka, Nikita, Jagruti, good morning. Okay, so first we will cover the historical or the basic aspects of paper chromatography. Okay, yeah. PC or the paper chromatography was first introduced by the German scientist Christian Friedrich Schonbein. Okay, so remember this name, Christian Friedrich Schonbein. It is important for your multiple choice exams. Okay, remember the year also, 1865. Christian Friedrich Schonbein, a German scientist. Remember, he is a German scientist. The first one to go with the paper chromatography. Importantly, the historically, which as we have already discussed in case of introduction to chromatography, that these chromatographic techniques historically been developed for identification and isolation of the color pigments, or more specifically the plant constituents. Okay, the plant constituents which are their interest of study has been separated out historically by so many scientists by using different techniques, and the techniques have been evolved from there onwards. Okay, and that's why the terms has been called as a chromatography. Chroma means color. Okay, so color pigments which are getting to be separated historically will be derived its name or origin from chromatography. Okay, but the major impetus or a major push in case of paper chromatographic evolution, or more specifically chromatography as a system evolution, has been came with the introduction of Martin and Singe in 1945. We have already discussed it, the contribution of Martin and Singe in 1945 and there onwards results into the variation and dimensional differences between the various chromatographic techniques. It may be simple paper chromatography with its various chromatographic or developmental techniques. It may be TLC, thin layer chromatography. It may be gas chromatography. These variations in chromatographic techniques will have its impetus or a more what we can say speed has been gained by 1945 with the tremendous amount of development and dedication by Martin and Singe. These two scientists have been awarded with Nobel Prize also for their contribution in chromatographic techniques. So the major impetus which we have get in case of paper chromatography is 1945 with Martin and Singe, but the first technique, paper chromatography word, has been introduced by Christian Friedrich Schonbein. Okay, paper chromatography is considered to be the simplest in the sense the instrumentation part, as we have discussed in case of your HPLC, as we have discussed in case of your gas chromatography, or even the further chromatographic techniques. It may be ion exchange chromatography, it may be your HPTLC, even TLC. These requires so-called as a sophisticated techniques and instruments. Okay, but in case of paper chromatography, it requires the simplest analytical instruments. Okay, as the word suggests, paper is a stationary phase used in case of paper chromatography. Simple solvents have been used. Solvents has been used for the solution purposes also, and a simple saturation chamber. This suffices with respect to the paper chromatography, and that's why there is a so-called as simple way of instrumentation. Hence it is widely used by so-called as amateur analytical chemists also. You need not be so-called as expert in case of chromatographic handling, as in case of HPLC, which is also the advantage as well as disadvantage of HPLC, because HPLC requires a specialized techniques of handling, and that's why training becomes must for handling the HPLC instruments. But this is not the prerequisite criteria in case of paper chromatography, because it is a simple technique and simple to handle technique, and that's why it is simplest technique and hence most widely used. No need to explain why it is most widely used technique, because of its simple and wide acceptance. It is widely used, and hence if you have a small amount of sample which you can easily separate out the sample by using paper chromatography. Okay, the simplest and most widely used chromatographic techniques because of its applicability. Remember, the dimensions of applications in case of chromatography does not get limited because of its simplicity. Okay, what I mean to say, whatever the applications are there in case of HPLC, that applications can also be applicable in case of paper chromatography, starting from your isolation and identification. Remember, the isolation and identifications can also be possible in case of paper chromatography and in case of HPLC. It can be helpful in determination of quantitative analysis or quantitative determination of organic as well as inorganic compounds. That means it is there for the qualitative and quantitative application. It is there for the application in case of isolation. It is there for the application in case of identification of unknown compounds. It is there for determine the concentration or a quantity of a substance which is there to be dissolved in case of your chromatography can be easily possible by using paper chromatography technique. Okay, yes, Amar, good morning. Samiksha, good morning. So the analysis of unknown substances can be possible by using paper chromatography. It's a simple and a very widely used technique just because of its flow of the solvents. Now, as we all know, the separation in case of chromatography dependent upon the two ways: solubility of a substance in the solvent or a mobile phase and its affinity towards the stationary phase. Affinity towards the stationary phase will determine the retention of your solute onto the stationary phase, and affinity towards the mobile phase will determine its carried away throughout the stationary phase. Okay, it's carried through the stationary phase. Let me explain it. Okay, there are 4 samples in this diagram. Okay, there are 4 samples in the diagram. Now this first sample can be said that it is having highest affinity for the stationary phase as compared to these three samples. Okay, this yellow sample will have the highest affinity for the stationary phase. Now stationary phase in case of paper chromatography is a simple paper. What that paper is called as a simple Whatman paper. There are variety of Whatman papers, but Whatman papers of number of series can be effectively employed in case of your paper chromatography. Now this first sample will be having highest affinity as compared to this last sample because of its affinity, or it is more soluble in the mobile phase as compared to its affinity towards the stationary phase, and that's why it is carried away inside the stationary phase towards the longer distance as compared to this yellow solvent or yellow simple mixture. Okay, so this is way by which you can easily compare out, or you can easily determine the unknown substance by comparing its contribution or its traveling distance with the reference. It may be this, it may be this, or it may be this, depending upon the spot you have kept for the reference purpose. Okay, so by comparing it with the reference, you can easily determine the unknown substance also. But there are two ways to classify the chromatographic techniques depending upon the principle by which the chromatographic separation occurs. We have already dealt it. Okay, and the developmental techniques by which the paper chromatographic techniques have been developed. So the first one is the principle by which the chromatographic technique have been developed. Okay, Seema, good morning. Paper adsorption chromatography and paper partition chromatography. No need to explain what should be the basis of classification. The first paper chromatographic technique involves adsorption as its separation principle. Okay, adsorption is its separation principle. Now for the adsorption, you need to have a solid surface, solid stationary phase, and that's why the paper has been impregnated with the silica crystals or the alumina crystals, acts as an adsorbent. Now, as we all know, adsorption cannot possible in case of your liquid stationary phase. So as soon as the adsorption words comes in your mind, it should be remembered that the stationary phase must be a solid phase, solid surface. Now if you are going for the paper adsorption chromatography, the paper has to be impregnated with some solid support or a solid stationary phase, and that solid stationary phase in case of paper adsorption chromatography employs a thin layer of your silica crystals or alumina crystal, which acts as an adsorbent or a stationary phase, and solvent is there depending upon the polarity of your molecule. Okay, so the adsorption in case of adsorption chromatography involves a solid silica gel, silica crystals on alumina on a paper and your mobile phase. Now in case of paper partition chromatography, as the word partition suggests, you need to have a liquid stationary phase, because somewhere in between the mobile liquid phase and a mobile stationary phase, your molecule, your compound will get partition in between, and you will get the separation out of it, as compared to your adsorption, where adsorptability of your molecule has been tested with respect to the stationary phase, which is always a stationary phase, which is always a solid. Okay, now the paper partition chromatography, the moisture, remember the word moisture or water present in the pores of the cellulose fibers. As we all know, paper, yes, Kadambari Lina, good morning. Paper, as we all know, is made up of what? Cellulose fibers. Now the cellulose fibers have the capacity to absorb the moisture or the water vapor present surrounding medium or in the atmosphere. Now these so-called the moisture, which are deliberately or undeliberately, intentionally or non-intentionally, has been there on the cellulose fiber, will act as your stationary phase, and as your mobile phase is already in the liquid, moisture is in liquid, you can easily carry out the separation by using partition chromatography in case of paper chromatography. Remember, the moisture and water will act as your stationary phase in case of paper partition chromatography. These moisture and water are present in the cellulose fibers present in the filter paper, acts as a stationary phase. Okay, another mobile phase is used as a solvent, and the mobile phase we all know. We will have a discussion on how to choose the mobile phase also. Okay, in general PC means, that means paper chromatography means the paper partition chromatography. Remember, when we say the paper chromatography, in general it is always a paper partition chromatography because of its easy availability, because of its easy acceptability, because of its easy employability to the different organic and inorganic compounds. Most probably the simple cellulose fiber filter paper which employs the moisture or water vapor present on the pores of the cellulose fibers has been used for partition chromatography, and that's why when I call the paper chromatography, it is most of the time paper partition chromatography. Okay, Nahid, good morning. No need to explain, the principle for the separation is mainly based upon the partition rather than adsorption, but that doesn't mean adsorption is not the principle of paper chromatography. If you are going for the paper stationary phase, which is solid one, there is a principle called as adsorption, but for most of the practical purposes, when we say that paper chromatography, partition is the best principle or widely used principle in case of paper chromatography. Okay, cellulose layers in the filter paper contains the moisture which acts as a stationary phase, and organic solvents or buffer more specifically has been used in case of mobile phase depending upon the polarity, because polarity differences needs to be there so that you can get the effective resolution or a separation by using paper chromatography. Okay, so have you understood the basic principle and basis of paper chromatography, or even why this technique is so commonly used? Let me know in the comment box. Have you understood? If you have any queries, I'm moving ahead for the instrumentation because there is nothing which can explain more about it, because these developmental techniques are more important as per your syllabus, but the practical requirements can be employed from the stationary phase and the various papers which has been used. There are certain papers which needs to be treated separately and modified also. How you are going to apply the sample, we will have the practical for this also. What is the basis of selection of mobile phase or the choice of solvent? How the paper chromatography has its very developmental techniques. It may be your ascending chromatography, descending chromatography, ascending descending chromatography, radial chromatography, then there is your two-dimensional chromatography. Okay, and how you are going to detect or visualize the separation. Okay, yes, okay, understood. Okay, so this is what the basis of your practical requirements. Yeah, we are moving towards the paper chromatography. The stationary phase we are using in case of paper chromatography, most of the time it is a Whatman filter paper, but widely used. As we all know, Whatman filter paper can be easily available, and that's why there is no worry as compared to your columns which we have discussed in case of HPLC and GC, and how you need to integrate and maintain the stability of the column. There is no worry as such in case of paper chromatography. You can easily available with the Whatman filter paper of a different grades depending upon the pore sizes. Okay, depending upon the pore sizes, this Whatman filter paper needs to be there, like number 1, number 2, number 3 finest sizes, number 4, number 20, number 40, number 42. Depending upon the pore sizes, these may have the various numbers or different grades of Whatman filter paper. This is also dependent upon the solvent which you are the solute which you are going to choose or separate out. So the selection of Whatman filter paper not only dependent upon the pore size pore size, but it also depends upon the polarity or even the composition of your sample solution. Okay, and that's why this 41, 42 and 40 and even 30 range Whatman filter papers are widely used in case of your separation techniques for the paper chromatography. In general, this paper contains 98 to 99% of alpha form of cellulose and 0.3 to 1% of beta form of cellulose. These two cellulose forms are there in case of your Whatman filter paper. As we all know, it is made up of cellulose fibers, and out of which alpha cellulose contains 98 to 99% and beta cellulose, which is a varied form of your cellulose, will contains 0.3 to 1% of your filter paper. Now the factors that govern the choice of paper, as we all know, the nature of sample and the sample solvent used, depending upon the polarity, depending upon its retention capability, depending upon its partition capacity in between the solvent and in between the stationary phase, the paper needs to be chosen. Depending upon the analysis, depending upon which you need to be quantitative or qualitative analysis, these Whatman filter papers of different grades needs to be chosen, and the based upon the thickness of the paper and the pore size can also be there in case of Whatman filter paper. Okay, so the choice of paper needs to be governed by these three factors, depending upon the nature of the sample and solvent used, depending upon the quantitative or qualitative analysis which you are going to perform, and depending upon the thickness and pore size of the paper or Whatman filter paper. Okay, now if you have a certain amount of organic solvent which is not so called as easily separate out by using your simple filter paper, Whatman filter paper, you need to treat it so that it can become easily available for the separation purpose to act as a stationary phase. What I mean to say, the cellulose with a free hydroxyl component or a free hydroxyl functional group can be treated with a different amount of acids, with a different amount of bases, with different amount of resins, so that it can be converted into hydrophilic form, it can be converted into the hydrophobic form, or it can be converted into any acidic or basic form, so that your paper, or more specifically your stationary phase, will become suitable for a different organic compound which is not going to be isolated, which is not going to be purified, which is not going to be qualitated in case of your simple Whatman filter paper. So what I mean to say, there are certain so-called as a modified and treated filter papers which can be used, or more specifically not a filter papers, these are the modified papers which are more specifically used for the separation of different compounds which are not easily separated out by using your Whatman filter paper. Like in case of modified papers, so-called as a modified just because you wash it the filter paper by using acidic solution or a basic solution to make it compatible for the separation of your choice of compound. Okay, it may be treated with the glass fiber type paper. Okay, this is the modified paper. At a times you can convert your paper into the hydrophilic paper, like paper needs to be modified or treated with methanol. You can treat it with the formaldehyde, glycol or a glycerol and convert it into the more hydrophilic nature, so that you can easily separate out the constituents of the sample which are not going to be separated out by using simple Whatman paper. Okay, you can on the other side can convert your paper into the hydrophobic papers by just acetylation of the hydroxyl groups. The cellulose hydroxyl groups can be treated with acetylation and leads to the hydrophobic nature, or conversion of your cellulosic fibers or a cellulosic paper into a more hydrophobic nature, and hence, as we all know, hydrophobic natures involves a reverse phase chromatography, so that you can complete out the reverse phase chromatography also. So what I mean to say that, yes, Neha, good morning. We cannot limit ourselves to the Whatman filter paper also. Because of its so-called as the physical parameters, it may have a variety of Whatman filter paper different grades available with us. But if there is a simple way of transferring your filter paper by treatment with the different organic compounds, and by maximizing the separation of your organic compounds, you can treat the filter paper or even paper to the different chemicals and at a times convert it into the more basic form, a more acidic form, hydrophilic form, or a hydrophobic nature. So, okay, you can even convert your treatment or rather paper by treating it with the silica and alumina. As we all know, the adsorption paper chromatography involves treatment of your paper with the silica and alumina, or even you can treat it with the ion exchange reagents to convert it into the ion exchange chromatography. Okay, so the separation techniques will not be limited only in case of your Whatman filter paper. You can convert your paper into, or even the markets will have a ready-made availability with respect to these so-called as a varied chemical natures of your paper chromatographic Whatman filter papers. Okay, now this is some of the practical aspects we are going to cover it. I am going ahead with the reading only. Cut the paper into the desired size and shape. Okay, so the size and shape will be dependent upon the saturation chamber, will be dependent upon the availability of the Whatman filter paper. Okay, and dependent upon the number of constituents which are going to be separated. Okay, if you have multiple components, you need to increase the size and shape of the filter paper, and if you have a very limited amount of sample available or number of constituents available with you, you can go with the reference and then only sample, so that you can reduce the size also. Okay, now what you need to do, you need to draw a starting point, a starting line, or what they called it as a baseline at the end of the filter paper. Okay, baseline at the end of the filter paper. Here they have stated that starting line is marked on the paper with an ordinary pencil by using 5 cm from the bottom edge. Okay, so the bottom edge, it may depend, like in case of TLC which you have performed last year, we maintain the 1 and 1.5 5 cm will be the baseline or the starting line. Same can be employed in case of your paper chromatography, but for the most practical purposes you can use 5 cm as 5 cm as the starting line or the baseline. On the starting line, marks are 2 cm. Marks apart the 2 cm with each other. Remember, here is the starting line. Okay, this is the starting line, and you have to mark the number of samples by using 2 cm to be kept apart from one another. Okay, 2 cm from one another. If you have the 3 sample, out of which this is the reference and these 2 are sample number 1 and sample number 2, these 3 samples needs to be marked by using pencil, so that you can easily mark over there the sample also. Okay, so what is the practical requirements or the preparation of paper? You need to cut down the paper in the size and shape depending upon the different factors which I already discussed. Starting line needs to be drawn by the pencil from 5 cm to the bottom edge, and more specifically you can draw the 2 cm dots on it, so that you can easily apply the sample on the filter paper itself. Okay, now paper chromatography. Now preparation of sample. The first criteria for the preparation of sample needs to be the solubility of your sample solution. Okay, your sample needs to be soluble inside the solvent, so that you can prepare the proper amount of solution of it. Choice of suitable solvent for making the solution is very important. You need to dissolve your sample. You need to dissolve your sample in a particular solvent, so that it can be easily applied on these 3 dots. Okay, these 3 dots. Okay, these 3 dots needs to be employed by using a solution, and that for that purpose your solvent, your mixture or your compound needs to be solubilized into the solvent of your choice. Now the choice needs to be limited, because if your compound will not be soluble inside that particular solvent, it will not produce a homogeneous solution, and that's why the severity or the separation efficiency has to be decreased. Hence, to limit ourselves for the purpose, we need to choose the solvent which can make the solution into a homogeneous one. That means your solvent needs to be easily solubilized inside the solution. Okay, pure solutions can be applied directly to the paper, but solids are always dissolved in the small quantity for a suitable solvent. More importantly, if you have a solid samples, you can easily apply by dissolving it into the proper amount of solution. Okay, biological tissues are treated with the suitable solvents and their extracts obtained. If you have any biological tissues available with you, and if you are going to have a separation out of it, you need to treat it with the suitable solvent and then extract out of it. Okay, proteins, if you have a protein solutions, you can precipitate out with the help of alcohol. So that process is called the denaturation. Salts can be removed by the treatment with ion exchange resin. Ion exchange resins can be easily employed in case of your salts. Okay, now how you are going to apply the sample? Sample to be applied is dissolved in the mobile phase, or more specifically a solvent, not a mobile phase. Okay, not a mobile phase, a different solvent may be there. It may be constituent of your mobile phase or may not be a constituent of a mobile phase. Sample needs to be dissolved in the solvent and applied as a small spot on the origin line. Remember, here is it by using this small capillary. By using this small capillary, you can apply the small dot. You can apply the small dots on already marked surfaces on this so-called as your origin line. Okay, these origin lines will have your different samples. Using the capillary tube, or even you can use the micro pipette also. Okay, you can use capillary tube or even micro pipette also. A very low concentration is used to avoid the larger zone. Remember the solution. If you have a solution of your sample, here it is. Pure solutions can be applied directly on the paper. If suppose your compound of choice which you are going to resolve through the chromatography is already available in the form of solutions, you can easily apply it on the filter paper also. But what is the basis of effective solution resolution is that you need to have a very low concentration of your solution or a sample for a better resolution. Okay, to avoid the larger zones. And if you have a pure compound, a pure solution has been applied over it, it will produce a larger zone. It will produce a larger zone, and it becomes very difficult for us to identify and to quantify the zone also. Okay, so to avoid the larger zone, you need to dilute it. Dilute the pure solution into an appropriate solvent so that you can have a very low concentration at the application site itself. Okay, at the application site itself. The spot is dried on the filter paper and placed on the developing chamber. As soon as you apply the spot, just air dry it and place it into the developing chamber. This is called as your developing chamber, which is packed inside. And here it is the mobile phase at the down side, and this upside down is what your filter paper or a stationary phase. Okay, choice of solvent majorly dependent upon the polarity. The commonly employed solvents are polar solvents. Okay, now in case of paper chromatography, polar solvents are major choice, but the choice depends upon the nature of the substance to be separated. Remember, the choice needs to be there to be limited with respect to the solvent depending upon the choice, rather its partition capability, its polarity, and its adsorptability towards the stationary phase and as compared to your mobile phase. Okay, the pure solvents do not give the satisfactory separation. A mixture of the solvents of the suitable polarity may be used. If you use the pure solvent, maybe a methanol, maybe a water, maybe a acetone, so if you are not satisfied with the separation, you can go for a mixture of solvent. There is a possibility of having the mixture of solvent, just you need to maintain the proper amount of ratio for developing chamber. Okay, simple one. Okay, here is the lead which encloses this developing chamber. Okay, this encloses the developing chamber. let me clear it first. Okay. Solvent front is the way by which the solvent is traveling. Solvent is your what we can call it as a mobile phase. Here is the paper which acts as a stationary phase. A very simple way of chromatographic separation, what we can call it as a paper chromatography. Okay, so the mixture of solvent can be a choice. We will cover this paper chromatographic mobile phase and chromatographic chamber. You can have overlook of it. Okay, here is the composition. If you need hydrophilic mobile phase, remember you can have the luxury of using hydrophilic and hydrophobic mobile phase depending upon the polar capability of your sample. Okay, if you are having the choice of hydrophilic mobile phase, these needs to be understand. Okay, ये आपको याद रखना है, उनका composition ratio आपको याद रखना है. Isopropanol ammonia water is one of the composition of mobile phase. 9:1:2 means 9 component of isopropanol, 1 component is ammonia solution and 2 component is your water. Okay, if you have the methanol with you, you can go for the hydrophilic separation by using methanol water composition as to 4:1. Okay, if you have N-butanol, N-glycyl acetic acid and your water, you can go for the varied composition as to 4:1:5. Remember, you need to remember these mobile phase composition along with their ratio. Okay, isopropanol, ammonia water 9:1:2, methanol water 4:1, butanol, glycyl acetic acid and water 4:1:5. If you have the choice of going for the hydrophobic mobile phase, okay, hydrophobic mobile phase, it can be first dimethyl ether cyclohexane, okay, and kerosene 70% isopropanol. Exactly what is the composition, I think we will have to check it. Okay, I will revert back tomorrow. Okay, so the dimethyl ether cyclohexane and kerosene 70% isopropanol can be a composition in case of hydrophobic mobile phase. Remember these compositions. Okay, so the next of the part we will cover in tomorrow's session. Okay, if you have any query you can ask me. Otherwise we will wind up our session. Developmental techniques, another important component. What is ascending developmental techniques, what is descending, ascending, descending, circular and radial development, 2-dimensional developments. Then there is how you are going to dry it, how we are going to visualize it. So the remaining part we will cover in the next session. Okay, if you have